Hello, welcome back to my channel. Today I'll be going over how to do mole conversions, specifically one-step mole conversions. So we're going to first talk about molar mass, how to find that, and then go use molar mass to do one-step mole conversions. So from mole to mass and mass to mole. So first off, what is molar mass? Molar mass is basically the atomic mass that you find on the periodic table, and it's grams per mole. So actually, when you look at your periodic table, let's say if we look at this model here, silicon, the atomic mass is 28.086. So for molar mass, it's basically the same thing as atomic mass, but the definition is different. Okay, so molar mass basically means 1 mole of silicon, or 1 mole of any element, equals this amount of grams. So one thing, or 1 mole of silicon, is 28.086 grams. So the units for that will always be grams per mole. So it's easy to find molar mass of specific elements. All you have to look at is the actual atomic mass. But the question is how to find molar mass of compounds. So let's say I ask you to find the molar mass of CO2. I have 1 C and 2 O's. So all you have to do is find the atomic masses for each of these elements, and then you're going to add them together. So carbon has the molar mass of 12.011. And there's only 1 carbon, so we just leave it as 12.011. And then oxygen, the mass for that is 15.999. Now, a lot of these masses, they're very it's very tempting to round, especially when the 0.99 or the 0.00. It's very important that you use all of the digits, so that way your total molar mass will be accurate, and then that'll help with eventually help with your mole conversions to have an accurate answer at the end. So oxygen is 15.999, and there's 2 of them. So I'm just going to multiply that by 2. So when you simply calculate that, you get 31.998. All you have to do is just plug that into the calculator. And then you have these 2 numbers, and you simply add them together. And when you add these 2 numbers together, you get your grand total of 44.009 grams per mole. That is the units per molar mass. Simple as that. Okay, so basically 1 mole of carbon dioxide, 1 mole of CO2, equals 44.009 grams per mole. So I'll give you one example to try by yourself. NH3. You do the same setup just to get to the hang of it, and then freeze the screen to try it on your own, and then unpause to check your work. Okay, so this should be your molar mass for NH3, 17.031. I have 1 nitrogen with a mass of 14.007, and then hydrogen is 1.008, and there's 3 of them. So that comes to be 3.024. Add those 2, and that is your grand total. So that is molar mass. Now for one-step mole conversions, we're going to first start off with mole to mass. Basically, you're given the mole, and you're trying to find the mass. And as a reminder, mass is the same as grams. Mole is mole, and the abbreviation for mole is just MOL. So I'll give you an example that will work out together. So let's say I give you a problem. Say how many grams, or it can even say calculate the mass. Again, mass and grams are the same. How many grams are in 5.37 mole of CO2. Okay, so if you're not strong in math problems like these, especially if questions get very wordy, obviously this question isn't wordy at all, it's pretty straightforward, but get into the habit of highlighting or underlining what is important and boxing what you need to find at the end, so that way you can really break down the question and narrow it down so it's less intimidating. So I know that this is important. I am given this number, and that is what I'm starting with. And then I am trying to find the grams. That is my goal. Okay, so since I'm starting off with 5.37 mole of CO2, we're going to use dimensional analysis. to convert that using molar mass times. Then we're going to build another ratio here, and this is one step. So this is the entire setup that you need. And please get into the habit of writing your units down, because the units literally tell you what to do next. If I just put 5.37, I don't know what you're talking about. 5.37 what? Grams, moles, atoms, particles. You don't know. So basically, you take the mole of CO2, do not carry the number down, just the unit diagonal, so that way we cancel out the unit that we don't need anymore. We don't want mole, we want gram. That's the purpose of converting. So grams of CO2 is what we're looking for. Now that we have both of our units taken care of, that's when we look at our numbers. So this is grams per mole. We just talked about this. That is the units for molar mass. So grams would be the mass from the periodic table, and we just found that earlier, 44.009, and then it's always per 1 mole, always 1 mole. And from there, you solve. So that pretty much cancels out the mole of CO2, and then you end up with grams. So this is a basic, basically a giant fraction at this point. So all you have to do is 5.37 times 44.009, and then divide it by 1. But as you know, dividing by 1, it stays the same. So when you plug this in, 5.37 times 44.009, you get 236. Let's round this to the nearest hundredths place. So 236, or yeah, 236.33 grams, because that is my end goal of CO2. Okay. So let's also do mole to particle. Okay, so mole to particle. Particle is basically when you use the Avogadro's number, the 6.02 times 10 to the power of 23. So you got to know the difference when to use the molar mass and when to use the Avogadro's number. And this is a constant. You will always use this number whenever particles are involved. So if I ask the same question, but instead of how many grams, I ask you how many particles we're going to use the same number here, 5.37 mole of CO2. The setup is pretty much the same. It's just the ending point. So we start off with 5.37 mole of CO2 over 1. And again, we cancel out that unit, mole CO2. And then it's always 1. And then since we're looking for particle, we have to use the Avogadro's number. 6.02 times 10 to the power of 23 particles CO2. Again, units, units, units. Very important. And then from there, you just multiply. 5.37, and this is just as a reminder of how to plug this in. 5.37, especially in this calculator, multiply by 6.02, and with the times 10 to the power, I highly recommend doing that E button there. So with this calculator, even if you have the TI-84, press that second button, and whatever key is above the 7, it doesn't matter what this key looks like, you will see that double E there. Press that, you'll get that tiny capital E, and then your exponent. Do not write 10 times or anything. Just 6.02, E represents that exponent, and then you write the exponent number itself. Equals, and that is your final answer there. Let's do it in hundredths place. 3.23 times 10. Notice how it's that little 24 there. Times 10 to the power of 24 particles of CO2. All right, so I'm going to give you 2 examples, one of each. Try on your own. and try the work on your own. Pause the video and then unpause whenever you're done to check your work. So for this one is how many grams are in 3.53 moles of H2O, and then at the same time let's just do how many particles, so using that same number of H2O. So again, freeze the screen, or pause the video and then check your work once you're done. Okay, so this should be your final answers for how many grams of H2O if you start with this many moles, and how many particles. So take a look at the setup. It is pretty much the same of what we did before. So this is essentially one step going from mole to gram, mole to particle. Now let's try doing the other way around. So I have these two more examples here where we're actually starting with particles or starting with grams, and we want moles. So let's first off start off with this question. But again, same method with the dimensional analysis. Always start off with what we're given. 5.36 times 10 to the power of 17 particles H2O over 1 times. Now, previously you just multiplied by the Avogadro's number, right? But that's to find particles. But to find moles, it's opposite. So notice how particles H2O is up here. We got to match it diagonally. We have to put particles H2O down here. So instead of multiplying, we're going to eventually divide. And it's always over 1 mole. And the constant, again, for Avogadro's number is 6.02 times 10 to the power of 23 particles. So when you solve for this, again, it's a big fraction. The big idea is basically you multiply across top divided by bottom. That's the main thing. But then the ones really, it's not that they don't matter. They definitely do, but they cancel each other out anyway. So you're going to just divide 5.36 times 10. So 5.36 E17. And you're going to divide by your Avogadro, 6.02 E23. So notice if you get something like this, again, if you have your TI-84s, it'll automatically be in scientific. But with this calculator, you may have to manually switch it to scientific notation. This is in normal mode, in standard mode, and if you see a bunch of zeros, it freaks you out, you gotta change it to scientific. So you just press that second button, and the button right next to that, see it has Sci/English. So Sci, that's what we want. We're gonna press that button. Flow, this is the standard mode. That's when you see a bunch of zeros. Move over to Sci, hit enter, it automatically changes to scientific notation. So I'm going to say 8.9 times 10 to the power of -7. And it is mole H2O. Alright, now for this next problem, you are starting with 137 grams of H2O, and again, you're looking for moles. So start off with what you're given. We have 137 grams of H2O. Build our next ratio. Grams of H2O, again, move that diagonally. And then it's always mole on the opposite side. Again, with grams, always use the molar mass from the periodic table, and we just found the mass of water in those previous examples that I had you do, and the mass for water is 18.015, and then it's always over 1 mole. And then here, you just divide, and it's simple division, simple numbers, no scientific notation. So 137 divided by 18.015. And see this 7.6, and this, since it's in scientific, but it says, if it says times 10 to the power of 0, that means nothing. So it's just 7.60 moles. All right. I'll give you 2 more examples to try on your own, and then you will pause the video, do it by yourself, and then check your work once you're done. Alright, here are these 2 questions. How many moles are in 115.75 grams of NH3? And then how many moles are in 7.52 times 10 to the power of 32 particles of NH3? Try it out. Alright, these are your final answers. The first one should be around 6.8 moles NH3, and then the next one is 1.25 times 10 to the power of -9 moles of NH3. So you can see the work there, how both of these are division. But that pretty much wraps up one-step mole conversions with grams and particles. So I hope this video helped, and have a great day. Thank you for watching.